Welcome to the day in history for June 4th. Today is the day. In 1946, one of the largest solar prominences ever recorded took place. It was a giant stream of plasma over 300,000 miles long. Absolutely crazy. Now, today's about space, but it's not really about space because we're not talking about like spaceships and NASA and stuff. We're talking about like the sun. So I would think of this more of like planetary geology or something like that, but it's going to be pretty cool. So our location is the surface of the sun. Our object of interest is superheated ball of gas, which is the sun, and our category is sciencey stuff. So here we go. Why don't you write this down? Now, the big idea for today is that the sun is more than just a bright circle in the sky. There's a lot more going on than just a super bright thing that you're not supposed to look at. So let's get going. Now, we are in the Orion arm of the Milky Way galaxy. Okay, so that's where our sun is. You can see that little arrow down there. The Milky Way galaxy is really big. Yeah, you knew that though. So now we're going to take a quick tour of the sun. Now the sun was formed when a a solar nebula collapsed upon itself about 4.5 billion years ago. Now this is a pretty good little diagram of how the solar system formed. And when the solar system formed, well, that's when the sun formed. And these gases all started gathering and spinning and coming together and then smashing and then eventually becoming the sun. So now the sun, whatever was left over, formed the planets, and that's why we're here. And so the sun, though, contains like 99 point something percent of all of the weight, of all of the stuff, of all of the mass in our solar system. The Earth and the other planets account for just a tiny amount of the actual objects in space or in our solar system. Now, the sun is usually broken up into six parts. We have the corona, which is the outside part that you can see when there's a solar eclipse. You have the chromosphere, the photosphere, the convection and radiation zones, which are inside the sun, and then you have the actual core of the sun itself. So this would be a good thing to do follow-up on because there's a lot of information about these 6 different layers. Now, when I was looking at what the sun is actually made of, I kept coming up with 2 different things. I would find sites that were like good sites saying that 71% of the sun was hydrogen. But then I would see something else about how 91% of the sun was hydrogen. And it turns out there's the percentage of atoms and the percentage of mass, so weight versus actual atoms. And because hydrogen is super light, it makes up 91% of the total amount, but only 71% of the total weight. So it can be a little confusing. But if you look at this chart here, you can see how most of the sun is hydrogen and helium. Everything else is like 0.078 or 78 thousandths is oxygen. And it gets even smaller from there. So, pretty cool. Now, the sun does a couple things. Now, first of all, it gives off light. Now, it gives off, actually, you know what, I was trying to have Penny help me out here and I screwed up the slides. Again, you'd think by the time we got to this far, I wouldn't mess up, but it's okay. Let's talk about what actually happens in the sun. Penny, you did right, don't worry, my fault, sorry. Okay, so, here's what happens with the sun. Thermonuclear fusion. Now we all know, I hope we all know, that the sun is crazy massive. It has so much weight. And all of that weight is pushing down, and it pushes down so hard, it actually takes the the hydrogen atoms, and it smashes them together to create helium. Hydrogen to helium. And when that happens, it's called thermonuclear fusion. And when those combine, when those hydrogen atoms get smashed into helium, they give off radiation, electricity, solar wind, and most importantly, light. And that's why the sun is shining right now, okay? The sun is shining because hydrogen atoms are being smashed together and turned into helium and releasing light and energy. Pretty crazy, isn't it? Now, the sun is giant. Over 100 Earths can fit across this thing. Now, that is a lot of energy being put out. It also creates a giant gravity well, or it gives space, the fabric of space, those indentations that we talked about when we did the Einstein Day in history. Now, most importantly, I think this one's probably the most important. The sun creates a giant magnetic field, and these are actually magnetic field lines that NASA put out. But these magnetic fields are so huge, they protect our entire solar system from the solar wind. Now, there's this galactic radiation that's just flowing through the Milky Way galaxy. And the sun creates what we call the heliosphere, which is like a protective field that keeps this radiation from, well, destroying everything. This is a really cool picture of what the heliosphere looks like. And it's got the Voyager 1 and Voyager 2 spacecraft in it, so you can kind of see how big we're talking about, because those spaceships have been going for a long time. Now, let's talk about 3 separate things. We have a pretty good idea of what the sun does, but the sun isn't just this perfect orange ball. Okay, sometimes it kind of looks that way, but oftentimes we have things called sunspots, and we might have talked about these before. And with my telescope, with the right filter, you know that filter that I held up and you guys looked through? You can actually see the sunspots. Now, but there's something called a solar max and a solar min, or minimum. Now, what happens is because of those magnetic fields, sometimes it creates like places where it gets a little bit cooler because the plasma is coming up to the surface. It's almost like there's cool spots on the sun. And when I say cool, I'm not talking like, ice cubes or anything. It's still crazy hot, but it's cooler than areas around it. Now, the next 3 things that we're going to talk about, which include sunspots, they're all related because these different spots allow for plasma to come up from the different layers of the sun and actually shoot out. Now, sunspots are pretty cool because they have a schedule, and we've been tracking it for a long time. Solar maximum, solar minimum, solar maximum, solar minimum. And as you can see by these charts here, it's pretty consistent. Sometimes it's a little higher, sometimes it's a little lower, but for the most part, we can predict the solar max and the solar min. Solar sunspots, another really good follow-up topic. Now, let's talk about the solar prominence. Now, this is what we're actually talking about today. Now, the solar prominence is when those sunspots give off a plasma, and the plasma goes out and then it gets caught in the magnetic field and comes back. You can actually see the magnetic fields of the sun with these solar prominences. Pretty crazy. Now, the one we're talking about today from 1946 is insanely large, and I found a picture of it from 1946. Look at that. That is absolutely amazingly huge. 300,000 miles across. A solar prominence shot out of the sun. This blew me away. I know I was going to try and do funny days in history, but I had to do this. I mean, there was a lot of important days in history today that I skipped over because I didn't want to talk about depressing things, but this is pretty cool. Now, there's something else though. So those are solar prominences. Now we're going to talk about solar flares. Now, solar flares are a little bit different from solar prominences because they're quick explosions. Now, they follow the same sort of path. It's superheated plasma from the different layers of the sun that shoot out, but these can be giant explosions. Now, this is one of the largest solar flares ever recorded, 2010, or it might have been 2012, but it is huge. And solar flares are kind of dangerous because they give off a giant burst of radiation, and that radiation can actually hit the Earth, and it can screw up communications, satellites, electricity, stuff like that. It also can add to the aurora borealis and some of the interesting stuff that happens in the atmosphere with charged particles and Earth's magnetic field and cool stuff like that. Now, the sun is a pretty important thing, I think we can all agree, but it's not going to last forever. They think in about 6.5, 7 billion years, the sun's actually going to turn into a red giant. Let's see. Do you see that? A red giant, which is actually going to engulf and destroy the inner planets. And then shortly after, it's going to collapse into a white dwarf. Now, guys, we're talking about 6.5 billion years. That's a long, long time. So, pretty interesting stuff. Now, if you go to YouTube and you Google size of stars, you can watch that video that we watched last year. Fourth graders, you should check this out. It is a super cool video about how big the different stars are, and it will blow your mind. So, ladies and gentlemen, solar prominences, now you know. See ya.